Hello Internet, my name is Quentin and this is Blondihacks. I'm back on the Pennsylvania A3 switcher this week and we're going to finish the side rods. So this is the first real piece of running gear on the locomotive and these are very intricate parts. We've got a lot of work to do, a lot of material to remove in very specific ways, which is, I guess, the definition of machining. Anyway, let's go. When last we left our little locomotive, it was chooching pretty good, but those side rods are very crude blanks at the moment. So let's see what we can do about that. Quick sidebar on the suspension. I had a lot of people ask why the crank pins have an hourglass shape to them, and this is why. It's so that the suspension can move while still allowing those rigidly connected side rods to remain rigidly connected. You can see that the hourglass shape of the crank pins, even though it's only a few microns of difference in the middle, allows that tilting action of the rods on the bearings. Steam locomotive designers were very clever people, and there's a lot more of these machines than you might have realized. But let's finish those rods. The first thing I want to do is create reference surfaces top and bottom. Right now the only valid references I have on these are the holes themselves. The top and bottom of these pieces are still unmachined, and I'm going to need some edges for subsequent setups. So using some reference pins in those holes on some parallels on my vise, I was able to effectively transfer those centerline hole references to an edge reference on top of the part. And then once I've got a valid reference on the top, I can flip the part over sitting on a parallel and create a parallel reference surface on the bottom. This is not strictly necessary for the final part, but it's going to help me with setups, as you'll see. To begin roughing in the shape of these rods, I need a vertical reference from, once again, the center line of these holes, because that's how it's specified in the drawing. So I'm using a feeler gauge on my end mill to find the top surface of that pin, then a little bit of math to go down from here by the thickness of the feeler plus the radius of the pin, and then back up to the dimension that I need on the quill DRO, and then I can start creating surfaces on the top that are going to be correctly referenced from the center lines of those holes. After skimming everything down to the top surface of the highest point on the final rods, I then begin hollowing out the center. I'm leaving little nubs on the tops above each hole, and those are the starting points for bosses for the lubricators that will eventually be there. And then the areas in between, you can see that I'm bringing down to the final top dimension of the top of the rod, starting to create that kind of barbell shape that the rods will have. I did this in two halves because each little oiler boss is referenced from its own respective bore, so I used separate references for each just to make sure they land in the right place. Then for the other rod, I used a gauge pin in that hole on the end, and used an end stop so I could swap the rods in and out accurately without having to redo all of that reference finding that I just did. The ends of these rough cut pieces of bar stock, of course, can't be used for reference. Again, I've only got the holes for x-axis reference, so a gauge pin and an end stop takes care of that. The second rod was then roughed in the same way. Luckily, these two rods are identical except for handedness. Now time for the exciting and stressful part, and that is rounding the ends. This is a special fixture plate that I made for my rotary table, so I'll center up the hole on the rod with a pin in the chuck, as you see there, clamp that down, and then normally I would have to get it aligned at this point, but I got incredibly lucky and it ended up aligned perfectly straight right off the bat. When does that ever happen? I do have to align the second one though, so I will show you how I do that. Then I can use the center bore there as a second clamping point, and we can start machining this. Now, the rotary table is set at the exact right angle for the end of the rounded point on the end of this rod. How do I know where to put that angle? Well, you can calculate it probably, but I just drew it up in CAD and had CAD tell me what that angle was, so I knew where to stop on the rotary table. I have a lot of material to remove, so rather than try to do it in a whole bunch of side milling operations, I started by doing a bunch of plunge cuts all the way around the edge to remove the bulk of it. Plunge cutting is a much quicker way to remove a whole bunch of material, especially if it's a thin end mill that isn't very rigid, and so you can't take heavy side milling cuts with it. Then once I've got it nibbled away with a bunch of plunge cuts, then I can come in for a finishing cut and side mill all the way around from the start and end points of the angles that I determined in CAD for where this feature needs to start and end. Now I can hear you all typing furiously, "Ermagerd, you're dumb, you've cut into your fixture plate." Calm down. Unhook your caps lock key. This is a sacrificial fixture plate. It's designed to be used this way. It's specifically designed so that I can take light cuts into it and then periodically resurface it. That's why it's so thick. Hold your comments and questions on this. I'm doing an entire video on this fixture plate where I will explain the entire philosophy and design of it. Let's just focus on the side rods here. Cool? Cool. That rotary cut seems to have gone well. These types of cuts are always nerve-wracking because it's really hard to see what you're doing on the rotary table, and it can be tricky to know if you're starting and stopping in exactly the right place to make sure all your curved tangents and such line up, but that seems to have gone well. Then there's also a little curved section on the other side of the lubricator boss, so that took a little bit of finesse as well. And I also did some x-axis action to blend the tangents of those surfaces together. There's a lot of skill and finesse in rotary table setups, and it takes a lot of practice to get really good results. It's one of those things that I think beginners may not realize. They assume a rotary table is just a magic solution to perfect matching curve tangents, but it actually takes a lot of practice and skill to get good results, which I did pretty good at. I'm actually really happy with that. That's one of my better rotary table features. Now I can flip it around and do the other end, which I did have to tap in, so I'll show you how I did that. I anchor it with the gauge pin at the head end so that as I tap it in straight, the center is staying centered. And then I do it a little bit at a time, checking how straight it is, and then I put the gauge pin back in and I tap it in a little further, and then I check it in how straight it is, and back and forth until I've got it running straight. And that way I never have to recenter the center hole on the spindle of the mill. It's remaining centered as I do this. Thus, the other three ends were all done the same way, and here's the current state of the rods. And of course, we did a little bit of damage to the surface plate, but once again, that's how it's designed. Hold your comments. I did have to do a little bit of filing and blending and so on, and I'll be doing a fair bit more before these rods are finished, but I'm just trying to keep things nice as I go along at least. You can never quite get the curve tangents perfectly aligned with a rotary table. Well, at least I don't. At this point, you can start to see the rods taking shape inside of this material, but we've got a bunch of operations now that are going to need a fixture block of some sort to hang on to them. So that's what I'm going to make next. I found this chunk of aluminum in the scrap bins. I'm going to start by creating a reference surface along one edge of this. I'm just going to take a quick fly cut along one edge. That'll create a flat surface from which to create other reference surfaces to create a nice holding fixture for a bunch more operations on these rods. Then I can put that reference surface down on the mill table and take a light side milling cut down one side of the block. And this is simultaneously going to create a flat square reference surface with the bottom surface that we created, and it's also going to create a surface that's parallel to the x-axis of the mill. As long as our cut is deep enough to do a full cleanup all the way down, then we've guaranteed ourselves a parallel surface on the mill x-axis without needing to dial anything in. Taking a cut on a block in situ is a very fast way to get an instant perfect reference fixture surface. As long as you don't move the piece, of course. I can't loosen those strap clamps or we will lose this reference. Now I can bolt the rod to that reference surface using some threaded holes that I tapped previously off camera before creating the reference side mill that you just saw. Now, of course, threaded holes in oversized bores are not going to be valid XZ references, so the rods are going to be crooked, and I'll start by straightening them right now. I indicate those in using that top edge, which is a valid reference edge, of course, because remember it was machined in a setup where I had referenced the center lines of those bores, so this is going to be valid to straighten it this way. Once that's tapped in nice and straight, then I can start thinning out the rods, which is the next step. I initially tried to do this with a long reach 1/4 inch end mill that I happen to have because the rods need an 1/8 inch radius at each end. So I thought this would allow me to thin it out and create the radii in one step. Unfortunately, this really long end mill was deflecting too much. It was not cutting well, it wasn't cutting straight, it was just a mess. So I gave up on that, and I started out with a much bigger end mill to side mill the bulk of the rod down to final dimension, which went just fine because this is a nice beefy end mill, no deflection, cutting great. But of course I can't get close enough to the rod ends with this larger end mill, and the final radius is going to be too large. So this can't be the finishing cut. So I need to go back to that 1/4 inch end mill. However, instead of trying to side mill it, what I can do is plunge cut with it. Even though it's very, very long and skinny end mill, if I come in and just do little plunge cuts, moving the table over a small amount at a time, like 10,000ths at a time, I can do a series of plunge cuts to eat away the larger radius left by the big end mill and bring that surface up to the final position right next to the rod end where it's supposed to finish with that nice little 1/8 inch radius curve. Now that'll need a little bit of filing to smooth out all of those little plunge cuts. It's not going to leave perfect tool marks, but as you can see, it's pretty good right off of the tool. A little bit of filing and you'll never know that that's how I did that. You may have noticed I didn't thin the material out all the way down. I left a thick spot at the bottom. And that's a suggestion in the drawings that's very clever, because what that allows us to do now is turn the piece around and do the other side, and that thick section at the bottom is supporting the work up against the fixture block. Otherwise, it would deflect inward as we were trying to cut the thin section in the middle, because the middle is unsupported since it's now thinner than the ends of the rods. But thanks to that support strip along the bottom, I can side mill this just like we did the other side, and everything works just fine. This is a great technique that I would not have thought of, and it's why I love Kozo's books so much, because they're just full of great little ideas like this that, even if you're not building a locomotive, might come in handy someday. With that thinning done, we no longer need this big extra strip along the bottom, so I set both rods up in the vise like this and just milled it off. I can't get all the way down to final rod width with this big end mill in a vertical setup because we need an end radius on these areas as well, so then I got to go to this setup. This is the same fixture block, but I've got the reference surface facing up now and the rod bolted down. Once again, I tap it in straight using the reference surface on the top that we still have. And this will allow me to side mill in the bottom edge of the rod to final dimension, and also thus give us the 1/8 inch radius on this axis that we also need at each end of the rod. Now I have a problem though. The final width of the rod is measured from the centers of those bores that I'm using to clamp the rod down, so I can't access the reference that I need. I decided to call an audible here, and I drilled and tapped an extra little hole in my fixture block, and that allows me to put this large brass panhead screw that I found in my bin and use it to clamp right on that little oiler boss to hold the end of the rod in place so that I can temporarily remove this fixturing screw and then use a gauge pin in the spindle of the mill to get my 0, reference for the final dimension of the width of the rod on this axis. I can get centered up like that, zero my DRO there, then put my fixturing screw back in, and then remove that brass screw. And that brass screw just kept everything from moving while I obtained that reference. And then just verify that it didn't move while I was doing that, and it didn't, so we're golden. Then in with a 1/4 inch end mill to mill this down to dimension on the bottom edge. This I can do with side milling because I can use a much shorter end mill with this setup. I could have modified this fixture block to allow me easier access. The fixture block is fairly tall, which is why I had to use that long 1/4 inch end mill that was too long and thin to side mill effectively with, but that would have been quite a bit of work, and I think what I ended up doing was actually easier. Then once again, some careful work at the ends to do my best to match up the radius that I'm creating with this end mill on this axis with the radius that was already created by the rotary table at this point. That did seem to go well though, and I think we are done with this rod, at least in this setup. So both rods were brought to this point. They're looking pretty good, but of course that was a lot of radii created with different setups and different methods and trying to make sure everything all lines up perfectly, and at least in my shop it's never going to, so then there was a whole lot of blending by hand with various needle files. I also did a lot of stoning and a lot of sanding to improve finish and remove tool marks. These side rods are kind of the showpiece of the locomotive, so I really want to make sure they're as nice as I can possibly make them. I spent a lot of time making sure everything blended together smoothly on all the surfaces. Finally, we need some tiny little threaded holes for oilers that will eventually go in the tops of these. And of course the bearings will need to be drilled out as well so that the oil can get through onto the crank pins, because the crank pin is the actual bearing surface. And that should be it. The side rods should be done. I'll put the bearings back in and install them and see how they fit. These rods were quite complicated to make, and it's kind of shocking how much material I ended up removing from the blank that we started with. I'm really glad I normalized them first, because if they hadn't warped early and given me a little warning shot across my bow like they did, then I would probably have warped rods right now, and I would be sad, because there's like 10% of the molecules of steel left from when I started, but I'm really pleased with the final result. I think they came out great. They're not perfect, but the goal is always to make it as good as I know I can with my current skill set, especially for really visible parts like these, and I can say with confidence that I have done that. These parts are as good as I can make them. Not as good as some people can make them, but they're as good as I can, and that's my goal. I'm really happy with them. They're definitely in the top 3 or top 5 of nicest parts I've made for the locomotive so far. Well, I hope you enjoyed the process of seeing how these were made. I hope you maybe learned some tricks even if you're not building a locomotive. Thank you very much for watching. Thanks especially to my patrons who make all of this content possible every single week. Couldn't do this without you all. And I will see you next time.